Hello and welcome to this deep dive into the JLeverX manual lever espresso maker as a supplemental video for the upcoming Kickstarter campaign. In this video we'll go through exactly how this thing works, its features, advantages and disadvantages. We'll pull a few shots and do some thermal testing, and we'll do a full teardown and so much more. This video is rather long, so I've put in chapters. Just skip to the chapter that you're interested in and let's go. JLeverX is a startup founded by myself to launch the JLeverX. I will be hiring some customer service staff after a successful Kickstarter campaign. Having said that, a lot of the work required so far was and will continue to be outsourced, so there are a lot of people involved even at this stage. They are firstly an award-winning industrial design house here in Australia. There were a team of 2 or 3 core industrial designers that have worked on the project over the last 3 years or so. Secondly, on the manufacturing side, we have a highly competent and experienced Canadian-owned contract manufacturer in China that's helped to develop the unit and the tooling and will be responsible for manufacturing. So that gives you an idea of the core competencies of the team that's building the JLeverX. All production tooling for the JLeverX and associated components are essentially complete, bar a few minor fit and finish changes. The project itself represents almost 5 years of developmental work, hundreds of prototypes of individual parts, probably something approaching 50,000 man-hours worth of work in design, testing, engineering, tooling and refinement, just to give you an idea of the scale of the effort involved. If you've been following the story from the start, this project went from 7 tools to now 30 tools. 30 tools we've cut and finished. It was certainly an expensive endeavor, a lot more than I anticipated. But anyway, all you need to know is that all the major technical showstoppers have been solved after multiple delays, and there is nothing but longevity and pressure cycling tests on the cylinder and some food grade certifications left. JLeverX is purely a manual espresso maker designed to be easily and fully dismantleable and easily repairable and serviceable by the owner. No electronics, no pumps, no motors. It is not a push button appliance or a pod machine. You will still need to learn some espresso dialing and puck prep skills. It of course cannot steam milk. For that you'll need any one of the number of options available today. Secondly, you will also need a good grinder and a fast boiling water kettle if you don't have one. So why did we build this thing? Well, we wanted a mechanically simple, very reliable manual espresso maker that combines ease of use from a physical perspective, speed of use for both single and multiple shots, exceptional versatility in the type of shots it can pull, but more importantly, capable of genuine espresso parameters, both in temperature and pressure. And we wanted all of that and still have good aesthetics and a tiny kitchen footprint. You can find machines that do a few of those things exceptionally well, but not all together in the one package, not at this price point. That is the gap that the JLeverX is designed to fill. Espresso machine manufacturers go to great lengths and costs to precisely control water temperature for a good reason. It is fundamental to espresso. Top-down flowing manual espresso makers struggle to reach an appropriate extraction temperature due to water stratification phenomena, where when hot water is poured into the main cylinder, it cools rapidly in contact with metal and then falls to the bottom layers and stratifies, and that's what you're using to pull your shot. That means that even with multiple rounds of preheating, they struggle to reach a 95-degree water temperature needed for something like a light roast, where a high temperature is needed to cut the acidity and to increase extraction yield. The JLeverX is different, being a bottom to up flowing espresso maker in that it actually relies on hot water cylinder stratification, where you pull your shot with the hottest stratified layer first, leaving behind that cooler water that was used to preheat the cylinder at the bottom of the cylinder. This hot water stratification principle naturally reproduces a commercial machine's high water temperature stability with a slight temperature decline, making your espresso as sweet as your beans allow, since espresso sweetness typically peaks at about 92 to 93 degrees centigrade. The JLeverX, as we shall see, does not need preheating for most roasts. For very light roasts, you will need to briefly preheat the unit to hit that 95 degree temperature mark. Preheating involves pouring boiling water into the cylinder and waiting a few seconds and then pouring out, which is very easy on this unit in a kitchen setting. However, we don't just need the potential for high temperatures, we need the ability to control temperature for different roasts. So we designed in something that could be termed a Vernier temperature scale that uses the boiling point of water as an accurate temperature reference point versus a thermometer, and it works something like this. The thermal mass and wall thickness of the cylinder is tuned specifically to the internal volume of the cylinder, such that based on heat capacitance sums, when 100 degree boiling water is poured into the unit, the heat that the metal cylinder pulls from the water will drop the starting shot temperature to the cylinder temperature divided by 10 plus 90 degrees. So for example, if your cylinder is at 20 degrees room temperature, we divide by 10 to get 2 degrees, add 90 degrees to get a 92 degree starting shot temperature. Or let's say we want 95 degrees, then we need to preheat the cylinder to at least 50 degrees, divide that by 10 to get 5 degrees, add 90 and we get 95 degrees as our starting shot temperature. For very dark roasts, which call for 88 degrees, as another example, we know at room temperature our cylinder will pull 8 degrees from the water, so all we need to do is let the kettle cool to 96 degrees, so that when you subtract 8 degrees you get 88 degrees. This method gives you a very good chance of achieving a desired extraction temperature intuitively without electronics or thermometers. I'd say within an error bar of about 1.5 degrees, as it does have some limitations. So let's have a look at some testing now. Okay, so first and foremost we have to make sure our probe is calibrated. We're at sea level here in Melbourne, so it should read about 100 degrees centigrade for immersion in light boiled water. Next we need to suspend our probe about a centimeter below our hypothetical puck, and I'm going to use some duct tape to fix it into place. Now I will also need some duct tape on the inside of the cylinder because I want to measure the temperature using a non-contact thermometer, and it is only calibrated to read accurately for high emissivity surfaces. Metal of course is a low emissivity surface, so we need a high emissivity spot in contact with the cylinder as a proxy. And we measure about 28 degrees. It is a hot day in Australia and a warm room, so by our Vernier temperature scale we divide 28 by 10 to get 2.8, add 90, and we're expecting 92.8. I'm a little slow here, but you can see the observed starting temperature is right on the dot at 92.5. Next we simulate our shot for 25 seconds. We do typically get about a 3 degree temperature drop. That does depend slightly on the temperature of the silicon cover. So now our cylinder is preheated. We can simulate a preheated shot. We measure 57 degrees centigrade, as you can see. Divide by 10, add 90, and we're expecting 95.7. But you do have to be fast with this Vernier temperature scale to be accurate, and you have to use water that is actively in a soft rolling boil at 100 degrees, else you'll be pulling it a couple of degrees lower. And you can see it's right on the dot again at 95. So science does work, surprise, surprise. So that's the Vernier temperature scale, a very accurate and intuitive way to get a starting shot temperature. And again we see a 3 degree temperature drop. Lastly, on temperature and heat retention, we put a lot of effort into the insulating cover, specifically focusing on reducing the 3 relevant heat loss mechanisms: conduction, convection and radiation, using grooves on the inside and outside of the cover. a polished metal cylinder which has a very low emissivity and a few other tricks. I'll spare you the science lecture, but the end result is that the unit has exceptional heat retention while being very comfortable to hold even after multiple shots. The other main benefit of a bottom to up flow is that it allows us to harness gravity to work in our favor during that early low pressure pre-infusion phase, where an upwardly moving flooding plane wets the puck evenly, reducing the chances for channeling, improving extraction yield and consistency, making our shots just that little bit more vibrant. On a top-down flowing espresso maker, water rains down unevenly on a puck depending on how good your shower screen is, and gravity works against us by pulling down these leading waterfronts in the puck, making them worse, as opposed to a bottom to up flowing espresso maker where the process acts to even out water flow through the puck. The last main benefit of a bottom to up flow design is that it directly allows us to view our shots front and center. We can immediately identify any extraction and or channeling issues. Let's now look at a few examples to see how we can identify flow issues on the JLeverX and what to look for. So we'll shake first in our dosing cup, and what we'll do first is a slightly poor job using the WDT in leveling with a slightly off level surface. I'm not sure if you can see that. And we'll do a slightly off level tamp, as you can see on our level indicator. Now, by the way, if you see that, you can kind of mash the tamper and tilt it the other way to get it to a level surface, and that's almost as good as a level tamp. Paper filter on top and our metal retainer, and we're ready to pull our shot. In goes the hot water. We typically fill about halfway to the larger cylinder diameter. And you'll see here I suspend the top over the cylinder for a couple of seconds. That's because I want to clear the air pocket under the basket. And we start our shot with a little pre-infusion, but straight away you can see that somewhat lopsided uneven fill. Technically that's all we need to see to know that it's not going to be as good as it could be. The second clue is, of course, if there is more flow through one section of the puck, you'll see bulk sideways movement across the surface as coffee kind of turns over in the container. And the third clue, not always the best indicator, as some fresh roasts will show bubbles at the end no matter what you do, but certainly lopsided or localized bubbles will mean that there hasn't been proper flow through some section of the puck and it didn't extract all that well. So let's just quickly look at an ideal shot. Shake, level the surface with the WDT and then do a level tamp. And that covers the three forms of distribution that need to happen inside the puck for a perfect shot each time. Microscopic distribution of fines with shaking, and the two macroscopic distributions, even density and even puck thickness with the WDT and level tamper. Now we're ready to pull our shot, and you'll see here, apart from ringing, the holes fill evenly across the basket. Ringing happens during pre-infusion because water will shoot down the sides of the basket at low pressure, but as soon as pressure is applied, those side channels get cut off. And since the sides of the puck are generally the least extracted, we actually want to see a bit of ringing, and we don't see any bulk movement of the top surface apart from a general upwelling. So that's what an ideal shot looks like on this unit. The difference between an ideal shot and a less than ideal shot is noticeable in taste, but it's really only maybe a maximum of 10% extra extraction yield. Now note, the safety screen can fog up. There are special anti-fog coatings you can get, or you can just use some dry soap to help it resist fogging. Now, speaking of shot diagnosis, one critical aspect to get a good shot is good puck prep. Our recommendation is grind, shake, distribute and tamp. Simple and standard for home espresso enthusiasts these days. All required tools are included except those required for shaking. For this I just recommend a dosing cup and cover from your grinder of course you can always go with a blind shaker. I've discussed why shaking is important and how it works from a statistical perspective in a previous video. Moving on to the other critical parameters for excellent espresso, namely the 6 to 9 bar pressure. 9 bar as a maximum pressure is a lot to generate manually, especially when you're pulling multiple shots for people and or over long term. The JLeverX has in fact 4 leverage mechanisms so as to not overstress parts and the user. They are firstly a reduction in the cylinder diameter, reducing the force required on the piston. Secondly, we further split the force required between the two arms. The third and main leverage mechanism is of course the rather long length of the arms, producing a high piston to handle movement ratio. And lastly, we created a variable height piston mechanism with a dual wrist pin structure to modify the required user strength to generate the same cylinder pressure at various arm angles, so that the peak leverage is matched to the peak pressure required for a declining pressure lever shot. Here we recognize that ergonomically a person can only apply a maximum force at the start of the shot, activating the larger muscle groups, the pecs, the biceps and the triceps, and at the end of the shot activating the lats, while for that middle part of the shot the unit has to be highly leveraged to reduce the strength required by the user in that somewhat awkward handle-like position. Overall, the unit is extremely easy to use and almost anybody could reach the peak 6 to 9 bar pressure consistently without ever getting tired of using the unit over the long term. From the Espresso community's feedback, we also installed a pressure gauge that taps into the cylinder so you can see exactly what pressure you're applying during extraction. While we're on the pressure gauge, some notes on maintenance: we expect that you will need to periodically flush the inside of the pressure gauge arm with hot water, and perhaps at longer intervals you'll need to dismantle the pressure gauge arm altogether to clean the insides, as there is some potential for bacterial buildup in the extremities of the arm where water temperatures don't reach high enough to disinfect the arm. So now let's look at what kind of shots we can pull. Of course, there is the standard and recommended declining pressure lever profile, which consists of a sharp ramp in pressure to a peak, then a slow decline in pressure, the most natural shot to pull on the JLeverX. But we can also pull a straight 6 to 9 bar. You just need to press a little harder all the way to the end. And of course, you can also use pre-infusion and a lower pressure peak for lighter roasts to allow you to grind very fine to cut the acidity and boost the missing body and bitter complexity typical of a light roast. As for other non-espresso shots, you can pull ultra low pressure shots, almost like an AeroPress style shot with zero bypass, with or without a rest stage. So for example, if we want to introduce a periodic rest stage, we can just stop the shot and suspend it using the arms to allow air to come out and diffusion to do its thing to extract the larger grind size particles. This style of shot will produce a coffee closer to a pour over or a soup-like shot, which is popular these days if you use a pour over or a soup-like grind size. So the JLeverX is very versatile in what it can do. Putting all that aside, does the JLeverX pull an espresso as good as a good Australian cafe? Well, yes, it certainly can. I hope I've convinced you of that, but I want to be clear and honest about what that will take. So after you get the basics correct, good fresh coffee beans with an appropriate rest time, good water with a good high quality grinder, the quality of your shot is going to then largely depend on your skills as a home barista. Now, there are a couple of advantages cafes have. The first is in the luxury of syncing multiple shots to dial in that perfect espresso. You might not want to sync as many shots at home, and so your dial-in on average won't be as good. But secondly, a cafe will use a bag of beans within the ideal rest time, while a home user will consume beans over a longer period and potentially outside of the recommended rest time, we recommend partitioning your beans into jars at the start of the ideal rest time so that the last jar stays pressurized, fresh and unopened until it's ready to be used. Now, having said that, home users have a couple of advantages of their own. Firstly, they can buy high quality specialty coffee beans that are specific to their taste preferences, while cafes have to use beans with the broadest taste appeal to the majority of their customers. But secondly, home baristas have the time to do proper puck prep to get the extra extraction efficiencies for that extra vibrant cup. And perhaps thirdly, home baristas can do all the fancy pressure and temperature profiles if you want to explore nuances in the cup rather than just pulling a straight 9 bar. So at the end of the day, whether or not you'll get a better cup than a good quality Australian cafe really depends on you. There is a wealth of espresso knowledge that you can draw on online, but certainly you'll have the tools to pull a shot that's going to be as good as you can get anywhere. I also wanted to point out the exceptional unit stability during the shot. You'll note the JLeverX has a very low arm to base contact point. In fact, it's only about 1 centimeter off the bench, and so the unit feels unusually stable to use, almost like it's anchored to the bench. One of our goals was speed without compromise, so that you can go from turning on the kettle when walking into the kitchen to drinking espresso in under 2 minutes, depending on how fast your kettle boils. Let's put that to the test and see the supplied tools in action. So we go to time ourselves to see if we've achieved our 2-minute espresso goal. The unit will take anywhere from 150 milliliters to 170 milliliters of water depending on dose, but you typically want to boil, say, 200 milliliters just to make sure you're not short. And on a 240 volt kettle, that will take about a minute to boil, so you do have that time for grinding and puck prep. We don't gain that much in the way of extra puck prep care, perhaps 10% extra efficiency, but that is noticeable in the taste. Or to think of it another way, you're saving 10% on coffee. A bit of trivia: if everybody in the world that made espresso improved their extraction efficiency a mere 10%, did you know that works out to a saving of 1.5 million tons of annual CO2 emissions? That's like planting 63 million trees, if my calculations are correct. So somewhat worth it. Now, I didn't turn the unit sideways, so pouring was a bit awkward. We recommend turning the unit 90 degrees to pour from the side, as it's much easier to pour that way. You'll also notice the kettle is still technically boiling as I'm pouring. That's what you want if you want to achieve 92 degree starting temperature with a room temperature cylinder. Notice also I hovered the top cylinder. You'll need to do that with this existing unit with the 25mm basket to remove the air pocket under the basket, else you might get a bit of spillage. We might produce a shorter 23mm basket at some point. And there we are, that's about a 30-second shot, under 2 minutes, and you're drinking espresso. Lastly, for multiple shots, you can batch shots by preparing multiple baskets while waiting for a larger amount of water to boil in the kettle, and then pour all shots back to back so that nobody is waiting for their coffee. So let's demo these batch shots. They do save a little bit of time, as we'll see, but not that much, as you still need to grind and prep both baskets, and that does take about a minute each. The benefit of batch shots is the time between somebody getting their first shot and the next person getting the second shot is about a minute, so that's super fast if you're doing, say, 4 to 5 shots for a group of people. For a batch shot of 2, we're boiling a good 350 milliliters of water. So you have about 2 minutes to prep before the water boils. This time you'll notice I do turn the unit 90 degrees, as it's more comfortable to pour in from the side. I do actually overfill both units as I'm rushing in this instance, and you'll see a couple of drops of water come out for that second shot. I wanted to leave this in, as you do sometimes get a drip or two with this existing unit, depending on how careful you are to fill it, since there is a small amount of water that pulls above the cylinder seal. Now you'll also notice, because I overfill it, I didn't push the arms all the way down, as I could see coffee right up to the top edge. When this happens, after you pour off, you can't just undo the locking handle, or the arms will fall a fair way and the piston will push the top out to a point where water will spill. So after you pour off, do a purge to get the handles about 2 centimeters off the bench, at which point it's ideal to unlock the unit, as then the arms fall an ideal short distance so that the piston gets pushed up just enough to crack the suction seal, but not enough to cause spillage. You may have also observed I didn't empty the unit completely for that second shot. That's because the cylinder for that second shot is now preheated, and you want to leave a bit of cooler water in the cylinder to temper the temperature, or you're pulling it at 96 degrees for that second shot. But yeah, I did get this process down to about 3 minutes 30 for 2 shots. We're at 3:45 here in this clip. The non-return system we ended up implementing was a simple paper filter. So paper filters are mandatory unless you want spent coffee water to enter your cylinder, which will require an extra cleaning step to flush the cylinder. Cleanup is very simple. Rinse the basket top and the retainer plate. I recommend reusing the paper filter as it doesn't get clogged up easily. Just put aside to dry for next time. You don't need to rinse it, as any spent coffee grinds will dry and they can be brushed off before next use. So that's all the features and advantages. Now let's have a look at some of the trade-offs compared to other units. First and foremost is that you can't weigh your shots precisely during extraction. You can only judge roughly by the amount of water in the cylinder, and secondly by the amount of espresso you can see coming out the top, which can be quite deceptive due to the variable amounts of crema production depending on how fresh your roast is. However, if you're pulling the same dose, after a while you'll know how far to fill the cylinder to get the same espresso ratio for a bag of beans. Second disadvantage, you do need to pour off your espresso. You will need some physical dexterity to be able to hold the unit steady and the cup at the same time. Some elderly folks might need to consider this before purchasing. Thirdly, the arms are quite long during use. You will need a long slither of kitchen bench space, about 900 mils to pull a shot. Now you can pull your shot with one arm over a sink or over a stove. You can also pull perpendicular to the kitchen bench, but keep this in mind when purchasing. If you don't have the bench space, then this unit might not be for you. Also note the height of the unit is 505 millimeters with the arms, so you will need to check if that fits under your hanging kitchen cabinets, if that's where you want to store the unit. Lastly, it can get messy and you can get a few drips of water depending on how careful you are in putting down your basket top, as some water can get stuck above the seal. It's really a unit that is designed for a kitchen setting. It is not designed for a coffee bar unless you want to be walking back to your kitchen sink with spent basket tops to rinse them. So after all that, who is this unit for? Well, first and foremost, it is for people that want to buy and brew fresh specialty coffee beans, and those who are chasing the highest level of shot versatility and cup quality. But secondly, it's also for those that enjoy the more rewarding and more hands-on tactile brewing process versus a push-button automated process where cup quality typically suffers. With all the improvements in mechanical ease, faster workflow and overall versatility, I'd argue that the JLeverX removes some of the traditional barriers to entry that have come with such manual machines. And lastly, the JLeverX was developed for people that can't afford expensive espresso machines, but yet still want a premium cup that you get on these expensive machines and an enjoyable workflow experience. Over a 10-year period of typical home use, approximately 2 to 4 shots per day, servicing is expected to be minimal and largely limited to seals and hard-wearing parts. The intent is to supply a complete spares kit that allows at least 5 units of operation without requiring additional purchases. The primary consumables are silicone seals. Seals and parts will be available directly from JLeverEspresso.com and via local retailers in various countries if they stock the JLeverX, and we will also release open CAD molds that will allow third parties to produce these custom food grade replacement seals. If you're a couple and you switch to having a coffee in the morning on the JLeverX instead of buying one on the way to work, then as a very rough calculation, if you're saving say two $5 coffees a day, that's about $50 a week, times 52, that's $2,600 per year. So it's definitely worth a purchase over a 10-year period. That's quite a sum if you invest the savings. So the JLeverX will certainly pay for itself many times over. The unit is compatible with almost any 58mm basket. However, due to safety considerations, we're only recommending you use the included thicker walled high extraction basket and or any other thicker walled baskets such as the Passato HE, the Weber Uni basket or the Wafo style baskets. Our recommendation will be not to install the thinner wall traditional 58mm stamp baskets like the VST or the IMS, simply due to the potential safety issues as they are subject to fatigue after a very large number of shots. There is of course a safety splash screen to protect you, and if you install these baskets, we'd probably recommend you run them at 6 bar. I think 6 bar makes a better espresso anyway. The unit is also compatible with the step down 54 and 49mm baskets, which while they may be thin walled, given the smaller diameter, they shouldn't be as prone to fatiguing. Some more notes on safety. The bottom upflow design naturally clears air from the system so that there are no compressed air pockets in the unit when it's pressurized, which is a very important safety design aspect. The unit also includes a 12 bar safety pressure release system that will release water down through the piston in case you exceed 12 bars. It is self-resetting. There is also no plastic in contact with hot or cold water anywhere in the JLeverX. All water contacting parts are made of metal and all high quality food grade silicone. So just to show all components and how they are put together, let's do a teardown. Firstly, the silicone handle just slides out in case you need to swap out a safety screen. But I have to stress here, the unit will come mostly pre-assembled and you won't need to do most of this. On the coffee container, you may need to pull out the cylinder seal and give it a clean, and that basket will push out. You need to clean this every now and then as coffee oils will build up. Now to remove the cylinder, we need to lift the locking ring up from the base. Just lift the skirting and you'll see a slot on the locking ring. Just push the locking ring up. Note that we'll bulge the silicone cover as we want to push the locking ring up past those holding pillars on the inside of the silicone cover. Now, very important to save frustration, the cylinder can only be fully undone with the arms in the vertical position. Just use the locking handle to turn if it's tight, and then we can pull the cylinder off. Hold the piston vertical while lowering one arm, and we can service the O-ring. Or if you need to exchange a spring, you can just pull them out. You might need needle nose pliers for this, as the spring we have is slightly too weak in this existing prototype, and they will be made stronger. Pull the main piston wrist pin through and the piston will come off. The O-ring can come off. The pressure release button and the calibrated spring will just pop out. you will need a thin bit of something to push it through. I'm using a pen. The secondary wrist pin just pushes through to release the two hardened bushings. The arms then just slide out. And the plastic inserts can be lifted as shown. The main bearings and support shafts will then come out. Just lift the assembly and pull the shaft through the side holes. The pressure gauge arm fixing screw can be undone with a supplied Allen key. This is somewhat of a long process because we chose a fine thread so the bolt doesn't become loose during operation. Don't lose the pressure gauge arm O-ring. As you can see, it can easily fall out. The pressure gauge can now just unscrew. Now lastly, both the locking ring and cylinder cover can come off, and that's it. Now for the assembly and maintenance. Firstly, make sure to not use any oil or lubricant on the cylinder, as you don't want to compromise the heat insulation between the cylinder and the cover. So it is a bit of a struggle to get on. We recommend food grade coconut oil as a lubricant in general. It's thinner and doesn't last as long as silicone grease, for example. So it's up to you, but it is compatible with silicone and it is antibacterial, so I really like it as a lubricating solution. So screw in your pressure gauge arm. Getting the thread started on this pressure gauge arm is the trickiest part here, as it is a fine thread. Then the top pressure gauge just screws back on, but note it will still seal across the last turn, so if you need to orient the gauge face to face a certain direction, you can still do that. Now, you didn't see the disassembly of the silicone top cover, but you'll need to immerse this in hot water to disassemble, as it is a tight fit. Again, we advise using coconut oil to lock out any chance of water ingress in this top seal and to make installation easier. Coconut oil or silicone grease on the cylinder, as it may last longer. Now to install the basket, always insert the basket seal first. Don't use any lubricant on the outside of the seal. Then some coconut oil on the basket itself to make it easier to slide into place. The silicone cover for the locking ring handle just slides on. Make sure you have it the right way around. Next, clean and grease the O-ring. Again, coconut oil is recommended. Now you may need to service your pressure release valve, but we'll advise on the frequency of that. Insert the bearing sleeves. Align and thread through the secondary piston wrist pin. Again, I have to stress the unit will come pre-assembled and you don't really need to do this for maintenance. Next, insert the shafts and the roller bearings into the base. The arms go in. I probably recommend lubricating all of these with coconut oil. If you ever need to disassemble, we'll advise on a lubricant for the high pressure bushings. Then pop in the springs and that secondary hard silicone piston stabilizer O-ring. Align the cylinder locking ring gap with the square tab at the bottom of the cylinder cover, as this will make it easier to move the locking ring down into place. Make sure it's past those silicone pillars on the inside of the cover. Again, note the cylinder can only be fully rotated into place with the arms up. Now you can push the locking ring down, but note it has to be in the correct rotated position before it can come down. Food grade silicone grease or coconut oil on the cylinder's top seal section and where the piston runs so that the piston slides smoothly, and there you have it. Let's now look at what ships with each unit. Firstly, the unit itself, including one basket top with our modern high extraction 58mm basket, one 58mm tamper, one WDT tool, one magnetic 58mm funnel, one adjustable volumetric scoop, two puck metal retainer plates, one spare gasket set, one spare spring set, one 58mm basket filter pack, and one Allen key for the pressure gauge arm screw. Additional basket tops will be available and sold separately. Now you may or may not be aware we've developed a revolutionary separate technology called VFIPP, which helps to reduce dialing for espresso and almost completely eliminates channeling. This revolutionary technology will not unfortunately ship with the JLeverX Kickstarter units due to a number of reasons I won't go into, but one of which is that a manual espresso lever machine is well known to be quite forgiving in its nature. You will be able to purchase a JLeverX VFIPP kit at some stage, but the rollout will be quite slow in select countries. Lastly, I should mention the JLeverX was designed as a starting platform. We have many innovations planned. We'll try and make them as backwards compatible as we can with the original JLeverX. To mention a few, for example, there's VFIPP of course, but then there are plans for a native 54 and 49mm baskets, that is without the step in them, and a motorized JLeverX unit later. All manufacturing, assembly and quality control will take place in China with our experienced contract manufacturer. Shipping will be handled by a dedicated logistics partner. Launching regions and countries will generally align with countries serviced by Amazon Logistics, but exact shipping countries will be announced on the Kickstarter. In terms of pricing, we will have an early bird special, so make sure you subscribe to all our social media accounts and our mailing lists, as the first batch of units on the Kickstarter will be sold at deeper discounts, perhaps around that $250 USD mark, so you'll want to know as soon as it goes live, as there will only be a limited number of units sold at that price. In terms of a retail price, if you miss out on the early bird Kickstarter prices, we're aiming for around that $395 USD mark or so, but we'll need to finalize that. In closing, I want the JLeverX to be more than just about espresso. It embodies a return to well-designed, well-thought-out, mechanically simple, long-lasting, serviceable products with less waste and frustration. I also want to encourage a return to fresh, minimally processed foods made at home, rich in bioactive compounds that real foods and drink should provide. Basically, our greater goal is to create innovative products that encourage and empower people to make better choices, but without feeling like that choice is somehow a compromise. So I hope I convince you to support our Kickstarter when it comes out. If you have any questions, do ask them in the comment section below, and I'll try and answer them as best as I can. Thanks for watching, and I'll see you in future videos. Okay, just a quick important message, because the less money I spend on advertising, the cheaper the product can be. And I'll pass on all of those savings. So like, comment, subscribe by all means, but more importantly, jump on the coffee forums. So Reddit, the coffee forums, and the Discords, if somebody can post. Even if you're watching this in the middle of the Kickstarter, it's still worthwhile to share and to comment and to just bring awareness for the unit. Thanks so much in advance. And yeah, I'll see you in the next video.